Hello everyone. Today we will finish this chemical bonding. These are only topical past papers. Okay, start. So question number one is define electronegativity. Like electronegativity is power of an atom, power of an atom, power of an atom to attract electron pairs. Okay, electrons. Okay. For example, if there is a bond, if we have a bond between hydrogen and chlorine, and you people know chlorine is electronegative element, okay? So now this electronegative element actually pulling the electrons of this hydrogen towards itself, okay? So it is the reason it is electronegative and it is electropositive, okay? Explain why electronegativity increase across a period. We know like across the period, for example, if we have this boron, then C, N, O, and F. Okay, so it is across the period. We are moving left to right. Here we have atomic number 5, atomic number 6, 7, 8, and 9. So now you people can notice atomic number is increasing gradually. Proton number is actually increasing. Okay, boron has 2 shells, carbon also has 2 shells, nitrogen also has 2 shells, oxygen has 2 shells. So you people can see now across the period no extra electron is like no extra shell is being added. Okay, so if I write like the reason, so the first reason is you can say nuclear charge is increasing. So nuclear charge, proton numbers or nuclear charge increase, nuclear charge increase. And when this nuclear charge is increasing, so if it is a nucleus and the forces of attraction between nucleus and this electron, it is also gradually increasing. So how can I write this? Like increasing nuclear charge, and I can like attraction of bonding, increase in nuclear attraction, increase in nuclear attraction, left to right in nuclear attraction. Okay, you can download this PDF from my website onalevel.com. Okay, I will like provide you the link in the comment section or description, then you can easily download this. The Pauling electronegativity values, okay, these are the electronegativity values of different elements. Define electronegativity, we already saw power of an atom to attract electrons towards itself. Okay, oxygen and sulfur are in group 16. Group 16 is oxygen, then sulfur, selenium, and tellurium and polonium, so on. Okay, we know like down the group size increases. For example, it is oxygen, sulfur is more bigger, selenium is more bigger. Okay, so down the group size is increasing, and down the group electronegativity decrease. Okay, it is decreasing. Electronegativity value down the group, down the group, electronegativity decrease. Okay, why it is decreasing? You people can see bigger size mean from nucleus to the valence shell. Okay, the attraction is like smaller. Okay, little attraction. But if small size is there, then attraction between nucleus and electron is very strong. So when we move from top to bottom, electronegativity decrease. Okay, so now we can reason. Oxygen has lower protons and sulfur has more protons. Okay, oxygen has fewer shells. Okay, oxygen has like less number of protons, less protons, number one. Okay, and other thing we can write like bigger in size, sulfur is bigger in size, sulfur is bigger in size, or even you can say sulfur has more bigger in size. Okay, let me arrange this. Why it is now? It is fine. Okay. The diagram shows the arrangement of outer electrons in a molecule of carbon monoxide. You know, carbon monoxide is a covalent compound. Here we have this. So there is actually, we can say, carbon, how many bonds? 1, 2, 3, 4, 5, 6. It means carbon is connected with, like this, 3 bonds. And here you can see a lone pair of electron on this oxygen. And here you can see a lone pair of this carbon. And here you people can notice that one of the electron pair is different. So it means it's making a dative bond. Making a dative bond. Okay. The table states the electronegative value of carbon, nitrogen, oxygen. Electron carbon is 2.5, nitrogen 3, oxygen 3.5. Okay. What is the question? Question is, I think, on the next page. Okay. So the question is here. Use the electronegative value and relevant data. Okay. Number of electrons per molecule. Okay. So now we need to write number of electrons. We know one nitrogen, this atomic number of this nitrogen is 7. It means there are 7 electrons. Okay. But it is a nitrogen molecule. Nitrogen triple bonded with nitrogen. So 7 electron plus 7 electron from here, we will get this 14 electrons. So here we have 14 number of electrons. Okay. So what is atomic number of carbon is 6 and atomic number of oxygen is 8. So when 6 plus 8 proton number, 6 plus 6, 12, 13, 14. So there is only also 14 number of electrons. Okay. Type of intermolecular forces. So now you people can see, like in nitrogen molecule, both are same. Like there's no electronegativity difference. Both are similar. So they are actually non-polar. Non-polar. Okay. So when a molecule is non-polar, there is, you can say, temporary is temporary dipole. Temporary. Okay. Or you can say instantaneous. Instantaneous. When this molecule will come close to any other, like other polar compound, then it will become polar, but for a very short time. Okay. So if we see carbon and oxygen, we can say carbon and oxygen. Okay. So oxygen is more electronegative. It will bear partial negative charge and carbon will bear partial positive. So when there is polarity, when there is bigger electronegativity difference, it means there is a permanent dipole. Here it is a permanent dipole. Okay. Permanent dipole forces. Okay. So next question is, some electronegativity values are given. Okay. Use the data to suggest the nature of bonding in iron chloride. Here I have this iron 1.8 and chlorine 3.0. And this 3 mean there are like iron charges positive 3. It means we have this iron FeCl3. Okay. It is making positive 3 charge. One chlorine charge is -1. There are 3 chlorine. It means -3. Okay. So you people can see now iron is 1.8, chlorine is 3.0. So use the data. Now we have to figure out like what type of bonding it is. Okay. So we can see, is it covalent or ionic? What type of like bonding? Bonding is covalent in nature. There is covalent. Okay. Covalent bonding is there. And why? The reason is between chlorine and it is 3.0 electronegativity and iron is 1.8. Okay, so less electronegativity difference. Less electronegativity difference. Okay. Okay, next. Lithium is a metal, hydrogen is a non-metal, is an ionic compound. Draw dot and cross diagram of lithium. Include all electrons. Okay. We know atomic number of lithium is 3 and atomic number of hydrogen is 1. Okay, so when we will draw this lithium, there is like 2 electrons in the like first shell and 1 electron in the valence shell. Okay, it is lithium, and it is the structure of, we can say, a hydrogen. There's only one shell and there's only 1 electron. Okay, we know when this hydrogen will lithium will lose this electron, lithium ion, it is an hydrogen. Okay, so then we will get this outer, like no need to write now this outer, we will get this previous one, shell number 2. So now we will get this shell number 2, and overall it will become a positive 1 charge. And what about this hydride? Electron of hydrogen, and its electron is coming from this lithium. So it is a lithium ion, and it will become hydride ion, and the overall charge will become 1 negative. Okay. So species such as ammonium carbonate, phosphate are examples of molecular ions. Okay. Identify the species. Like now we have to figure out the species. Okay. Like which species we can say like ionic or covalent. Just we need to find it. Okay. So which is oppositely charged ion? Which one is making oppositely charged ion? Okay. Cation and anion. Identify the species that are electrostatically attracted to one another in. Okay, we can say it is a positive, like ammonium carbonate, ammonium phosphate. Okay, and ionic bond. So what are the species there? In ionic bond, there's a cation. One of the species is a cation, which is a positive charge ion, and other negative species known as anion. Okay. These are two species. Cation is a positive charge, anion is a negative charge. Okay, in ionic bond they are attracted with each other. Radium is an element found in group 2 of the periodic table. It is a crystalline solid at room temperature and conduct electricity. Okay, group 2 element, crystalline solid. It is solid, room temperature and conduct electricity. Radium chloride. Now it is a metal. Radium is a metal. Chlorine is a non-metal. Has a melting point 900. These are like a big value. Okay, and soluble in water. So now we have three clue number one, soluble in water, ionic property, ion melting point, ionic property, and other is one of the thing is metal, other is non-metal. So it means RaCl2 is ionic compound. It is actually ionic in nature. Okay, and soluble in water. So what is the question? We will find this question on the next page. Here, okay. The strength of, okay, the strength of interaction between particles determine whether the substance, oh sorry, very sorry, okay. Where is the lattice structure of based on the properties? It is ionic structure, okay, ionic. You can see it's a giant ionic structure. Giant ionic lattice, okay. Giant ionic lattice. Okay. Draw a dot and cross diagram to show arrangement of outer electrons. We know it is from group 2. R is from group 2. So it means there are 2 electrons in the outermost electron because it is from group 2. Electron 1 and electron 2. And chlorine, there are 2 chlorines. One chlorine is here, other chlorine is here. Okay. So there are 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7. And here I have 1, 2, 3, 4, 5, 6, and 7. It is for chlorine, and for radium. Okay. So now it is from group 2. It is 2 electrons in the valence shell. So now how to draw their structure? You know, it will lose 2 electrons. For example, one of the electron is moving here and other electron is moving here. Okay. So now we'll get the remaining shell. It will contain 8 electrons. The remaining one 8. 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Now, and now chlorine, this 1, 2, 3, 4, 5, 6, 7, and this cross is coming from here. Okay. And now I need to draw some other. Here it is. Here. 1, 2, 3, 4, 5, 6, 7, and 8. It is medium, ion, Cl and Cl. You know, the overall charge will become 1 negative. Same thing for this, because it is gaining 1 electron, and the charge of this ion, it will become 2 positive because it is losing 2 electrons from the outermost shell. Okay. The strength of interaction between particles determine whether the substance is solid, liquid, or gas at okay. Lithium sulfide. Lithium is metal, sulfur is non-metal. A crystalline solid with a melting point 938, high melting point. It conducts electricity when it molten. We know ionic compounds, they only conduct electricity when they are in molten or in aqueous condition. If they are in solid, they cannot conduct electricity. Okay. Give the formula of the particle present in sodium lithium sulfide. So we already know, like, it is a ionic compound and there are two type of particles. One of the particle is cation and other is anion. Okay, cation and anion. Cation, and so he's asking give the name of the particles. So we need to like name of the particles. Okay, so let me remove this from here. So what's the cation? Cation is lithium and anion is sulfide. Okay, cation is lithium. Here I can say right, cation is lithium ion. Lithium is from group 1, so positive 1 charge. Sulfide is from group 6, so negative 2 charge. And sulfide 2 negative charge. So cation and anion. Okay. Explain in terms of the structure of the crystalline solid why lithium sulfide has a high melting point, because strong electrostatic force. It is ionic. It is actually ionic compound. And when the compound is an ionic, we know there are strong forces of attraction, okay, between a cation and anion. Okay, so because they are opposite charge ions and opposite charge ions, they are strongly attracted to them. Okay, so next is magnesium silicide. Magnesium is a solid, silicon is a metallite. Okay, a compound made by heating magnesium with sand. Draw a dot and cross diagram to show this. Okay, the emit of outer. So now we have Mg2Si. We have Mg2Si. We need to draw the structure of this Mg2 term and silicon Si. Now we will know, like, silicon is from group 4. So silicon is from group 4. Okay, silicon is a member of group 4. So you can say there are 4 electrons in the valence shell of a silicon. There are, we can say 1, 2, 3, 4. So magnesium is from group 2. Magnesium is from group 2. Okay, so it means the magnesium can lose 2 electrons. Okay, here I have this one magnesium, here I have another magnesium, and it is the outer shell's electrons of first magnesium and outermost electron of this. So now I'm drawing 2 electrons, 1 and 2 here. 1, 2, 3, 4, 5, 6, 7, and 8. So 2 electrons, 1 and 2 here. Other 1, 2, 3, 4, 5, 6, 7, 8. So these 2 electrons are moving from here to here, and this electron. So 2 electrons are coming from this magnesium and 2 electrons are coming from this magnesium. Okay. So we will get the final answer. This magnesium ion, the remaining electron, the inner one, 1, 2, 3, 4, 5, 6, 7, 8. Okay, because the outermost 2 electron has gone. Okay. So one magnesium, here I have another magnesium, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and here I will draw this silicon. So it is electron coming from magnesium, magnesium from electron, and this is from magnesium, and it is from magnesium. So because it is receiving 4 electrons, so the charge will be 4 negative, and the charge of this 2 positive, and charge of this 2 positive. Okay, it is your final answer. Okay, this one. Okay, magnesium losing two electrons from here, and silicon is from group 4, 2 electrons from here and 2 electrons from here, so 4 negative charge. It is your final answer. Okay, draw a label diagram to show the structure bonding in sodium. You know sodium is a metal, group 1 metal. So when this is a group 1 metal, we can say it's the positive charge, and there's only 1 electron surrounded by 1 electron because it is from group 1. It is the reason there is only 1 electron. Okay, so you can like draw this type of structure: negative, negative, negative. Delocalized electrons, they are representing delocalized. Delocalized means free electron, they are movable electrons. Okay, next question. Okay, so we have this question: bismuth is an element in group 15 of the periodic table. Bismuth has a metallic bonding. Okay, draw a label diagram. Okay, group 15 mean like group 5. I think there's 5 electrons. So now I need to draw a bonding with 5. Okay, once again same positive ions in the center. Sorry, I need to change this. Okay, so now I'm drawing this positive ions, and there are delocalized electrons. Okay, there are delocalized electrons around these positive cations in metals. Okay, group 2 elements of magnesium to barium are all silvery white reactive metals. Draw a label diagram to show the bonding and structure of group 2 metal at room temperature. Show the bonding. Okay, group 2 metal. For example, I'm just central cation, and now I'm 2 electrons per atom because it is from group 2. 2 electrons per atom. Okay, because there are 2 electrons in the valence shell of this. So now I have this positive, and you can see this positive. Okay, why magnesium has higher electrical conductivity than sodium? We can notice in sodium, for example, there is 1 electron per atom, but group 2 means there are 2 electrons in valence shell per atom. Okay, magnesium has more electrons than sodium. Magnesium has more electrons than sodium. Okay, it has 1 electron per atom, it has 2 electrons per atom. Okay, bismuth is the dense metal in the same group as phosphorus. Draw a local label diagram, show the bonding. Bismuth is a metal, so once again same like cation with this surrounded by this negative, okay, electrons. So I'm not like solving this question again. Okay, for example, okay, magnesium, so reaction typical of group 2 metal. Draw a label diagram to show the bonding in magnesium metal. Once again 2 electrons per atom because it's from group 2. Something is from group 3, you will draw 3 electrons per atom. Cations, positive ions, and 2 electrons per atom. Okay, magnesium has a melting point 650 and high electrical conductivity. Explain these properties of magnesium by reference to structure and bonding. So magnesium is, high melting point, number 1, and electrical conductivity. Explain, because it is a metal. There's a metallic bonding. Okay, and what could be the like other reason? For example, let me arrange my tab. Okay, Okay, so high melting point. High melting point means there are strong forces of attraction. There are strong. There are strong forces of attraction. Okay, so because it's a metal, and you know this positive strongly attracted with this negative ion. Okay, it has high melting and boiling point, and electrical conductivity mean there are delocalized electrons. Conductivity mean there are delocalized mean free electrons, free moving electrons. Okay, delocalized electrons are there. Delocalized electrons. Okay, these delocalized or freely moving electrons are responsible for metals conductivity. Okay, it is the reason they can easily conduct electricity. So now we have next page. Okay, still I think all questions are low order question, very simple question. Okay, copper has a melting point 1085, a high melting point, and high electrical conductivity. Explain these properties of copper by referring to its structure and bonding. Once again, it is like metallic bond. Okay, and strong forces of attraction. It is a metallic bond. Sorry, all the time I need to change. Okay, it is actually a metallic bond. Metallic bonding, and strong forces of attraction. There are strong forces of attraction, okay, between cation and freely moving electron. Okay, complete the sentence. The reducing agent lithium aluminum hydride can be synthesized by reacting aluminum chloride with lithium hydride. Lithium aluminum hydride decomposes slowly to form lithium aluminum and hydrogen. Okay, it is broken down into lithium aluminum and hydrogen. Lithium aluminum show metallic bonding. Describe metallic bonding. So how to describe this metallic bonding? So we can say like cation positive ions surrounded by delocalized electrons. Okay, cations are cations are surrounded by, they are surrounded by free electrons, or even you can write delocalized electron. Delocalized electrons. Okay, okay. Name the type of bonding with a sample of solid copper. Copper is a metal, so the type of metal is a metallic bond. A metallic bond is a metallic bonding. Okay. So draw a label diagram to show the bonding within a sample of solid copper. Once again, positive cation, and they are free delocalized electrons. Okay. Then here, so draw carefully. Okay. Sometime he will give you some MCQs and he will draw different diagrams. So you people need some practice. Not a big one, is a difficult one. It is easy, but sometime he will like make such a structure which will make you confused. Okay. The model of the nuclear atom was first proposed by Ernst Rutherford. He developed this model on the basis of results containing from an experiment using gold foil. Here's the type of bonding in gold. Gold is a metal, so write the answer metallic bonding. Okay. Describe the metallic bond in gold. Once again, a cation is surrounded by cation is surrounded. It is surrounded by delocalized electrons. Delocalized. Delocalized electron. Okay, because it is a metal. Okay, next. Cerium is a lanthanoid. Lanthanoid means it is the part of lanthanum series. If you see the atomic number of lanthanum, I think 57, and from the 57 to onward elements, they are known as lanthanoid. Okay, that shows similar chemical reaction to some elements in this period. Most of cerium compounds contain C3 positive cerium because it is a transition metal from transition group. So it is they can have variable oxidation states. Okay. So next page is here. So question, cerium has the same structure bonding as a typical metal. Draw a label diagram to show the structure and bonding in cerium. So I'm not like drawing now because already I have multiple time. Okay, we already have done this question here. Positive with negative free localized electrons. Okay, here, then here, and then positive delocalized cations. Okay, these are actually delocalized electrons, free electrons. Okay, mobile electrons as well. Now questions from the dative bonding. Okay, so now we have the 3.1 and now we have to find its like structure and bonding. Okay, let me change this. It is from here. Okay, so we have this sulfur, carbon, there's a nitrogen. So no need to confuse. Okay, so we already know this like sulfur is from group 6. Sulfur normally can make 2 bonds and carbon can make 4 bonds. So I'm drawing 2 bonds with this sulfur, 8 bonds. Carbon is from group 4, it can make 2 bonds, double bond. So 4 bonds of carbon. So nitrogen can make how many? It is from group 5, so it can make 3 bonds. But here nitrogen is making 2 bonds. It is the reason there is a negative charge on this nitrogen. So it is the one possibility of the structure. Okay, I can like draw it here. Okay. So now how many electrons are there? For example, 1, 2, 3, and 4 electrons. So I can draw it here 1, 2, 3, and 4. Sulfur is from group 6, so it means there are lone pair of electron as well, just like this. I can draw it here lone pair of electrons. Okay. So next, another possibility is if I draw this, for example, sulfur is making a single bond with this carbon, and there's a triple bond with this nitrogen. Now nitrogen is making 3 complete bond, carbon is making 4, but now sulfur is incomplete. Because it is group 6, so we can say 1, 2, 3, 4, 5, 6. Okay. So there's another possibility. Okay. So because there's a negative charge here, it is also a negative charge. So even you can write this structure or this structure, both are correct. So don't be confused. Okay. So now I am drawing just lower one. Okay. So here I am drawing this lone pair of electron 1 to 3, and if there is a single bond, then I need to only one electron pair. I will draw only one electron pair, 1 and 1. So is there triple bonding? So triple bond means 6 electron, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So there's a one lone pair of electron because nitrogen contains 5 electrons in the valence shells. 3 electrons are taking part here, so remaining we will have this one. So this charge is actually because of this sulfur, because sulfur is comfortable with these 2 bonds, but here sulfur has only 1 bond. It is the reason there is a negative charge, and here is a negative charge all over the molecule. Okay. A molecule of sulfur chloride contains 2 sulfur chlorine covalent bonds. Complete the dot and crossed. Okay. So sulfur is from group 6. Okay. Sulfur is from group 6. It is like this: 1, 2, 3, and 4. 6 electron in the valence shell. And there is a chlorine, and chlorine is actually like this. Chlorine is from group 7. So we can say 1, 2, 3, 4, 5, 6, and 7 electron, and this electron is bonded with this like this. Sorry, chlorine 1, 2, 3, 4, 5, 6, and 7. Okay, so here it is the structure. So you can draw this here. How can I draw this? This is the like lone pair of this and this sulfur, and electron of sulfur, and it is electron of this chlorine here and here, and chlorine is making 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Because chlorine is from group 7, 7 electrons in the valence shell. Sulfur is from group 6, so there are 6 electrons. 1, 2, 3, 4, 5, and 6. Okay. So it is the shape of and bond angle in molecule of, we know this lone pair of electron. This lone pair of electron, it occupies more space. This lone pair of electron and this. They are actually repelling this. Repelling this. Okay, so you can say it's a bent shape. Shape is bent. Even you can write bent or V shape. Bent. It is making a structure just like a water H2O. Okay, so there's a bond, I think 104. Bond angle is there. 104. Okay, 104.5 degree. Okay, so bent shape, or even you can say it is a V shape. Okay, bent or V shape. Okay, why? Because this lone pair of electron around the central metal of sulfur, they are repelling these bond pairs, so that is why it is molecule, it is making a V shape. Okay, reverse V. Okay, so next question is from 2024. Okay, so this question from 2024, bond angle is 104, I think. Okay, 0.5. Boron nitride is a white solid melting point is 29, means it's a giant covalent structure. High melting in volume, high melting point, giant covalent structure. Okay, reduce the empirical formula of boron nitride. Empirical, which gives simplest. Okay, if I look at this structure, only this I have to. Okay, boron 1, 2, 3, B3, 3 borons. Nitrogen 1, 2, 3. There's nitrogen and 3. So ratio is between B to, and there is a ratio 3 ratio 3. If I simplify it, I will get this ratio 1 ratio 1. So the empirical formula will become Bn. Okay, it is an empirical formula. Bn. Empirical formula of boron is Bn. Bn. Okay. Suggest the identity of another crystalline solid that has the atoms arranged in the layers similar to that of solid. Oh, it's the graphite. Here we know graphite is also a giant structure. Okay, so graphite. I think so. It's a graphite. The layers form. Graphite is making a similar structure to this. Okay. Covalent bonding, a bond formed between like bond by like mutual sharing of electrons. Bond bond formed by mutual bond formed by mutual sharing of electrons. Okay, between atoms. Okay, a carbon-carbon double bond in an alkene is made from a sigma bond and a pi bond. Identify the hybridization of carbon atoms in a carbon-to-carbon double bond. Okay, so we know when we have carbon-to-carbon double bond, it means this carbon, as you can see my lecture about hybridization. Okay, so this carbon A, it is actually connected with this carbon 1, with this hydrogen, it is a 2, and here I have another hydrogen 3. When a carbon is connected with 3 things, it means there is sp2 hybridization. There is sp2. You can see my lecture about hybridization. Okay. Draw a label diagram to show in terms of orbital overlap how the segment pi bonds are made in. Okay. We know like sigma bond is formed by head-on-head approach. Carbon, it is like another carbon, and it is like one of the orbital of this carbon, and here is the head-on-head approach. Okay, pi bond is formed when we have this carbon, and there are unhybrid pz orbital. I already explained these things in my topic hybridization. Okay, so when this side to side approach, it is making a pi bond and it is making a sigma bond. Okay, questions are easy, they are not so difficult. Okay, ammonia react with HCl to produce ammonium chloride. Okay, draw a diagram to show the ionic, covalent, and coordinate bonding present in a formula unit of. Okay, why we are using the term this formula unit? Formula unit mean when there is some ionic bond. If there's ionic compound, then we use this term formula unit instead of molecular formula. Okay, so we have this ammonium chloride. We already know this. Nitrogen is from group 5. There are 5 electrons in the valence shell of a nitrogen. Okay. For example, we have this one electron, 1, 2, 3, 4, and 5. Right? Now, these 3 bonds, they are shared with one of the hydrogen. Like hydrogen, sorry, one hydrogen, it is also making a bond with this hydrogen and this. So, these 3 bonds are covalent bond. Okay. So what is a coordinate covalent bond or dative bond? When this lone pair of electron is attracted towards another hydrogen. So the dative bond is representing by this arrow. Okay, so this arrow is actually representing lone pair of electron. Lone pair, not a single electron. Lone pair of electron is attracted towards this hydrogen. So nitrogen is group 5. It is comfortable with 3 bonds, 1, 2, and 3. But now it is using its extra lone pair. Whenever you see an element uses extra lone pair of electron, it will bear a positive charge. So it will become ammonium. Okay. So there's a chlorine, Cl negative, and it is attracted with this positive and negative. So 1, 2, 3. These bonds are covalent. From lone pair to hydrogen, coordinate covalent or dative bonding. And a bond between this positive and negative, it is a ionic. Okay. So now I can draw this shape here like this. Covalent bonds. It is a coordinate covalent bond. Sorry, my bad. I need to put hydrogen here, okay, not a chlorine. So it's a positive charge on this nitrogen, and a chlorine will bear a negative charge. Okay. So next question we have: nitrogen is generally an unreactive molecule. Why? We know nitrogen molecule. It is making nitrogen to nitrogen triple covalent bond. Okay, and you know they are same elements, same atoms. Okay, so they are actually non-permanent, non-polar. They are permanent non-polar molecules. Okay, but it does react under certain conditions. Certain conditions mean when there's a very high temperature, for example lightning, for example in car engines. Okay, N2F2 molecule has a double covalent bond between its nitrogen atoms. So he is now telling us like between this nitrogen to nitrogen there is a double bond. Nitrogen to nitrogen there is this double bond. Okay, and nitrogen to fluorine there is a single bond because nitrogen maximum can make single bond. Okay, so now we need to draw their structure. Okay, so we know if there is a double bond, like there are 4 electrons, 1, 2, 3, and 4. I'm drawing it 1, 2, 3, and 4. Okay, so single bond between nitrogen and fluorine. So it is the electron of nitrogen and cross is the electron of this fluorine. Okay, same thing here. Now we know there is a lone pair of electron on each nitrogen. I'm drawing it lone pair of electron. They are actually known as bond pairs. Even you can say shared pair electron because they are being shared between these two nitrogens. It is also a shared pair of electron. It is lone pair of electron which is not taking part in a bonding. Okay, another lone pair of electron. Fluorine is from group 7, and we know there are 7 electrons in the valence shell of fluorine. Here we have this one electron. So now I need to draw 1, 2, 3, 4, 5, 6. So please be careful whenever you write this, write them in pair form. Okay. So once again, 1, 2, 3, 4, 5, and 6. Okay. Deduce the hybridization of the N atom in N2F. Normally, when we see the structure of this ammonia, here we can say a nitrogen is bonded with three elements and one of the lone pair. In ammonia case, it is sp3. It is sp3. But here we know, here we have nitrogen is bonded with a double bond. And I already explained this in hybridization topic. So now it is making sp2. When it is making a double bond, it is sp2. So I'm writing the answer sp2. Even I can make these lectures in Urdu language comfortable. My own language is Urdu. Of course, it is more comfortable for me and for Pakistani and Indian students. But I'm making these videos for like some other countries as well. Okay. Draw a diagram of the pi bond between the nitrogen atoms in N2F2 and describe how it forms. So now we are making a pi bond. We know, like when we have this one nitrogen and we have this other nitrogen, and pi bond is formed by side to side overlapping, side to side. Even we can see a parallel overlapping of these orbitals. So it is making this a pi bond. Okay, side to side overlapping is there. Okay. So next page is this. So we have this next question. POCl3 shows similar chemical properties to PCl5. POCl3 has a melting point of 1 degree, very low melting point. Boiling point 106, it is also a very low, just like some liquid type thing. Okay. POCl3 reacts vigorously with water, okay, forming misty fume. Misty fumes mean HCl. It is a famous term in your A levels. Misty fumes. HCl actually makes misty fumes, okay. And acidic solution. We know when we dissolve this in water, we will get, I think, HCl or phosphoric acid, okay, H3PO4. Explain how the information in D suggests the structure in bonding POCl3 is simple covalent. Number one reason is there's a small, low melting point and low boiling point, low melting point and boiling point. This is the first reason. It is like describing it as some covalent. Other, it reacts with water. Like it means there is hydrolysis. POCl3, PO, sorry, is capital. POCl3 went through hydrolysis reaction. So hydrolysis, okay. And we can see it here, okay. It is reacting with water, okay. POCl3 contain a double covalent bond between phosphorus and oxygen. Yeah, phosphorus is from group 5 and group 5 mean there are 5 electrons in the valence shell. 1, 2, 3, 4, 5. And it is making a double bond with this oxygen. And chlorine, you know, chlorine make a single bond, single covalent bond. So this type of structure it is, okay. Now, so now we need to draw their like arrangement of electrons. So if there's a double bond, 4 electrons are here, I can say alternate. I'm representing cross electrons for this phosphorus. So one cross is here, one cross is here, and one cross is here. So remaining I'm just like explaining with this dot. So there are two lone pair of electron on this oxygen because it is from group 6. Okay, there are 6 electrons the valence shell of oxygen, 1, 2, 3, 4, 5, and 6. Chlorine is from group 7. So 1, 2, 3, 4, 5, 6, and it is 7. 1, 2, 3, 4, 5, and 6. You can get this hard copy from Read and Write publication, and here is the website. Okay. So 1, 2, 3, 4, 5, and 6. Understand? I hope you people got this idea. Describe a covalent bond present between the carbon atoms in ethene molecule by completing table. Okay. So type of orbitals involved in bonding. Sigma bond. So we know in sigma bond, like what type of sp2 in ethene molecule. First I need to explain how to draw this ethene molecule. Ethene is when we have this carbon and carbon, and it is sp2, this orbital of sp2, because carbon is double bonded. When carbon is double bonded or connected with three things, it is sp2 hybridized. This carbon is connected with three things, one hydrogen, second and third this carbon. So these actually carbons are sp2. Okay. So this sigma bond is formed between sp2 and sp2. Okay. How it is sp2 I already explained everything in my hybridization topic. Okay. So it is sigma bond is formed between overlapping of sp2 overlapping with sp2. And how pi bond is formed, we know there's an unhybrid p is an unhybrid. It is not hybridized form. Okay. So it's side by side it is making a pi bond. So I can say type of orbitals, okay, sp2 and how the orbitals overlap. Okay, so here I can say p orbital overlap with p. Okay, and how orbitals, they are like head on head, you can say direct, they are head on head, or you can say they are directly overlapped with each other, and you can say sideways, or even you can say right parallel. So I'm writing a sideways according to marking scheme. Okay. Okay, if there is some background noise of vehicles, I'm sorry, really sorry for that. Okay, so the next question we have, species ammonium carbonate phosphate are examples of molecular ions. Question October number 22. Okay, ionic and covalent bond both involve electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another in a covalent bond. We know in a covalent bond, like shared pair of electron, we can see it is a some type of like covalent, like expression is just like covalent, but it's not covalent actually, it is ionic. Okay, so this electron pair is like shared between, and here is the nuclei of chlorine and nucleus of this aluminum. So this electron pair is actually attracted between this nucleus and this nucleus. So what type of species are there? Shared electrons pairs. Shared electrons pairs. I need to change my background for this black pen or blue. Okay, shared electrons and you can write nuclei. Okay. Okay, so these are three species. In the gas phase, AlCl3 exists at equilibrium with Al2Cl6. Okay, so reaction is exothermic because the overall reaction is negative sign. It is exo, it is releasing heat into the atmosphere, into surrounding. Complete dot and cross diagram to show the bonding. It is a very famous question. Okay, and we know like there is covalent bond as well as there is a dative bond. Okay, aluminum is from group 3. It can share 3 electrons, so one of the electrons being shared here, other is here. Here we will have some third chlorine. Okay, here just like this. So here's the electron of this aluminum. It is from group 3, 1, 2 and 3. So now each electron by chlorine, this and this. Chlorine is from group 7. One electron here, 1, 2, 3, 4, 5, 6, 7. And here 1, 2, 3, 4, 5 and 6. Now we need to draw a size structure another because it is Al2Cl6. Okay. So here we have another aluminum and with this circle. Sorry for this circle. Okay. And now there are 3 chlorine. 1. I have this 2. And here I have this 3. Okay. So electron of aluminum, aluminum and aluminum. So electron of this chlorine, chlorine and chlorine. It is a chlorine, chlorine and chlorine. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, and 6. So how to draw a dative bonding? Actually, the one of the lone pair of the chlorine, this lone pair is actually attracted toward this aluminum. It is making a dative bond. And the lone pair of this chlorine attracted toward this aluminum, it is making another dative bond. Okay, these are covalent, but it is a dative bond, coordinate covalent bond. G belong to a group of compound called ethers. Okay, so the question is just we should focus on the question. Draw a dot and cross diagram to show the arrangement of outer electrons in a carbon monoxide molecule. We know, we already solved the question. Carbon monoxide is like this. See, triple bond with this oxygen, and there's a one lone pair of electron here, and one lone pair of electron is here. Okay, so this type of structure is here. It is a carbon, and here I am drawing this oxygen. So 1, 2, 3, 4, 5, 6 electrons. 1, 2, 3, 4, 5, and 6. Because one of the electron lone pair is, this is a dative bond. It is actually a dative bond. Okay. So one of the lone pair on this here. So I'm representing electrons by this, and it is oxygens. And what about the carbon? I'm representing this with lone pair. Okay. So next page. I think questions are easy. Now, in the laboratory of hydrogen iodide can be formed in a two-step process. Iodine reacting with phosphorus, phosphorus iodide. Then phosphorus iodide react with water and we get phosphoric acid and hydrogen iodide. Draw a dot and cross diagram Pi3 molecule. Phosphorus, check the group number of phosphorus. It is from group 5. Group 5 means there are 5 electrons in the valence shell. 1, 2, 3, 4, 5. Now I will check group number of iodine. Iodine is from group 7 and they have the charge of -1 and they can make one bond. Okay, so phosphorus is making iodine is making one bond with this here, here, and here. Okay, so now I need to draw the structure in. Okay, so first it is the phosphorus, 5 electrons, 1, 2, and 3 iodine, 1 iodine, second iodine, and here I will draw this the third iodine. Okay, so this electron of phosphorus, phosphorus, and phosphorus, and electron of this iodine, iodine, and iodine. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, and 6. It is a phosphorus. It's an iodine, iodine, and iodine. Okay. So lithium and aluminum are elements in group 13 of the periodic table. Indium has very similar chemical properties to aluminum because they both are from the same group. It is. So the question is, draw a diagram that clearly shows the type of bond present in IN2Br6. It is the very same structure I already explained here, like this. Just instead of Al, you people need to write In, and here I will write In because aluminum and indium, they are belonging from the same group, group number 3 or 13. Okay. And here we have bromine instead of chlorine. Chlorine and bromine, they are also from the same group. So it is the 100% same structure for In2Br6. Okay. So let me draw even for you people In2Br6. Okay. I will draw just like this. I will draw this indium with this circle. Okay, one circle is here, second is here, and third bromine is here. Okay. So indium electron 1, 2, and 3 because it is from group 3 and it's electron of this bromine, and lone pair of electron of bromine, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 and 6. So I have another indium. Okay, so 1 2 and 3 bromines. Okay, so electron of indium, indium and indium, bromine, bromine and bromine. So it is 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. So this lone pair of electron attracted toward this indium, and this lone pair of electron of bromine. Okay, so it is the structure of In2 Br6. So we have this reaction, calcium react with acid making a salt, further heating the salt, calcium oxide. Then okay, what is the question actually? Calcium hydroxide is broken down into carbon dioxide, okay, converted to carbon dioxide with reaction 2. Then we have this carbonate with water, okay. So question is here, okay. So the question is, in reaction 4, calcium carbide is formed from calcium oxide. Calcium carbide. Calcium carbide. I think the structure of calcium carbide is like this. If I remember from my university time, calcium carbides. Two carbons are there. Okay, they are connected with this calcium. Okay, it is calcium carbide. Contain the C2. Okay, now we can see anion. Okay, carbon two anions, 1 and 2. Okay. Each carbon is a sp hybridized. Why? Because it is triple bond is there, so it is sp hybridized. Also sp. Okay. Describe how sp hybridized orbitals are formed. One s and one p. Mixing of you can intermixing of when you I can write mixing of s and p orbital. Okay. When one s and one p orbitals intermix together, we get sp. Sketch a diagram to show how sp hybridized orbitals can form a sigma bond. Sp hybrid orbitals can form a sigma bond. Okay. So if I have this, so they can make like sigma bond will form like this and like this. Okay. It is a sigma bond direct approach, head on head approach. Okay. So it is the one sp and it is another sp. Okay. Studies are compound that contain sulfur but no oxygen. Sulfides. Carbon disulfide is a volatile liquid. Volatile means that liquids evaporate at room temperature. Okay, for example, we have petrol, we have that nail polish removers. Okay, when we keep them at ordinary temperature, they evaporate by itself. So they are known as volatile liquid. Draw a dot and cross diagram of CS2 molecule. First, we need to understand carbon is from group 4. This carbon is from group 4 and there are 4 electrons. 1 electron, 2 electron, 3 and 4 in the valence shell. Okay. Sulfur is from group 6 and it can make 2 bonds and there are okay. It means this sulfur is here connected with this sulfur. Lone pair 1, 2, 3, 4 and this sulfur double bond 1, 2, 3, 4. So dot and cross, so I will draw this first carbon, one sulfur and other sulfur. Okay. So now 1, 2, 3, 4 lone pairs of electron, 1, 2, 3, 4. The sulfur, another sulfur, 1, 2, 3 and 4. Okay. So now carbon to carbon is double bond. So electron of sulfur and electron of this, then this 1, 2, 3 and 4. So I'm representing carbon's electron with cross, okay? Because double bond is there, so there are 4 electrons here, 4 electrons. It is a carbon, okay? The strength of interaction between particles determine whether the substance is solid, liquid, or gas at room temperature. Carbon monoxide is a gas at room temperature and pressure. It contains a coordinate bond. Explain what is meant by a coordinate bond. The bond formed by complete transfer of lone pair of electron. Okay, it is, you can write the bond formed by complete donation, not transfer. Complete donation of lone pair, not a single electron. Lone. If single electron, that is the ionic bond. It is lone pair of electrons. Okay. We know in coordinate this dative covalent bond. For example, we have this ammonia. It has this lone pair of electron, and we have this H positive. It is deficient of electron. Okay? It is deficient. It is electron rich. This lone pair of electron is attracted donation. It is donating this pair of electron to this, and this bond is coordinate covalent bond. Okay. Draw a dot and cross diagram to show the arrangement of outer electrons in CO. Show the electron. I think we already have done this carbon monoxide in previous topic. Okay. Carbon monoxide, nitrogen gas, both diatomic molecule diagram show the arrangement of outer electrons in the molecule of CO. Already we have solved this question. You can check from the previous. Okay. Of course, now I am saving my energy, saving my time. Okay. Okay. Luckily, he already has done. So we can see one of the electron pair is a dative bond. Okay. One of the electron pair is a dative bond. It means carbon is making triple bond with this oxygen, and one of the lone pair of oxygen is attracted toward this carbon, and lone pair of this, and here is a lone pair of this. Okay. State one similarity and one difference in the way the atoms in carbon monoxide molecules are bonded together compared to atoms in a nitrogen molecule. So we have this nitrogen molecule. So what is the similarity? We can say a covalent bonding. Similarity is a covalent bonding in the way the atoms. Covalent bonding. Okay, both have covalent bonding. Okay, while CO has one dative bond or coordinate covalent bond. You can write dative, or I'm writing dative. Dative bond. Okay. Similarity is both have covalent. The difference is it has one dative bond. Okay. Chlorine forms several oxides, including Cl2O, ClO2, and Cl2O6. Draw a dot and cross diagram of Cl2O show outer electrons. So now oxygen is from group 6 member. Oxygen is from group 6. Okay, 1, 2, 3, 4, 5, and 6 electrons are there in the outermost shell. Okay. Chlorine is from group 7. It makes only one bond. So it is a chlorine. Here it is another chlorine. Okay, it is oxygen. It is Cl and Cl. So now I need to draw there like electron of chlorine, electron of chlorine. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay. So next. The reducing agent lithium aluminum hydride can be synthesized by reacting aluminum chloride with lithium hydride. Draw the structure of Al2Cl6 showing fully. We already solved this. You can check this. Okay. So state the bond angle in AlCl3. AlCl3. Here we have this aluminum. Here we have this chlorine. Another chlorine. If question repeated, then I'm not solving it. Okay. So it is a trigonal. It is trigonal, and the bond angle in trigonal is 120 degree. It is 120 degree. Okay. When gallium is heated in excess, chlorine gallium trichloride is made. Draw the shape of the gallium trichloride molecule and suggest the bond angle shape. Okay, so gallium is from, is there any lone pair of electron? So we have this question. Okay, so it is similar to Ga2Cl6. Okay, so now we have the structure of oxide ion. Here we have this oxygen and this two negative. And we know one of the oxygen, if it is just like this, O and O, it means it is O2 molecule. Okay, but we can notice there is a two negative charge. It means one of the bond is missing. Like it means this oxygen, it is making a single bond with this other oxygen atom. It is negative one charge. It is also carrying a negative one charge. Okay. It is a normal O2 molecule and it is oxygen which is oxide ion. Okay. Draw dot and cross diagram for the peroxide ion. Show outer electron. So now I need to draw its structure. Okay. So we know oxygen has 6 electrons in the valence shell. One oxygen is here and other oxygen is here. So I already explained you there is a single covalent bond. So I am explaining the one electron from one oxygen and other electron from other. Okay. So because it has how many electrons? It has 6 electrons in the valence shell and one of the bond is making here. So meaning we will have this 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. Okay. But we can see like negative one charge is still there and there is still one negative charge. If I left unpaired electron, suppose if I left this unpair of electron, it will become a radical, but it is not a radical because it is bonded with some like oxide is bonded with some this sodium. It means one sodium is donating to electron this, it is donating an electron to this oxygen, and other sodium is donating electron to this oxygen. Now it is the actual structure of this. Okay, because if I'm not drawing this electron and this, it will become unpaired electron, and in case of unpaired electron it will become oxygen radical, which is extremely reactive species. Okay, because it is actually the part of Na2, it came from Na2O2. It means these two sodium atoms, one of the sodium atom donating to electron this oxygen and other sodium is donating electron to this by making a ionic bond. Okay, so it is the answer. Okay, this structure is the answer. Okay, HOF is the only known molecule, draw dot and cross, that contain only the elements hydrogen, oxygen, fluorine. Okay, electronic diagram represent bonding. Okay, so when we are arranging elements, keep in your mind the most electronegative element will come on the right hand side. We can see oxygen is electronegative, fluorine also electronegative, but fluorine is more electronegative. It is the reason it is on the right hand side. Okay, so I'm drawing first oxygen. Oxygen, it has 6 electrons in the valence shell, 1, 2, 3, 4, 5 and 6. Hydrogen is from group 1, it can make only one covalent bond, so I am carrying this electron here, electron of this hydrogen. Fluorine is from group 7, it also make a one covalent bond, electron of fluorine, and here is the lone pair of this fluorine, 1, 2, 3, 4, 5 and 6. We have this fluorine, central one is the oxygen, and here it is the hydrogen. Okay, so next question is here. HCl2 is formed in the following reaction. When H2Cl2 react with chlorine, we are getting these two molecules of this. So be dot and diagram to show the bonding in molecule of HCl2. So first, sulfur is from group 6. Sulfur is from group 6. 6 electron the valence shell, 1, 2, 3, 4. Chlorine make one bond, so I'm leaving one electron here, 1. So it is actually bonded with this X electron of this chlorine, and same thing will happen here. Okay, so now it is the sulfur. Now we have two lone pairs, 1, 2, 1 and 2. Two lone pairs, one electron of sulfur, and it is the electron of chlorine. Okay, and the remaining chlorine valence electrons, and here remaining chlorine valence electrons. Okay, it is the chlorine, and here we have this chlorine. Okay, nitrogen is the inert gas that make up 78% of the Earth's atmosphere. Draw a dot and cross diagram of nitrogen molecule show outward. So we know there's a nitrogen to nitrogen, there is a triple covalent bond. It is the reason it is unreactive. Okay, so how can I draw a shape? I need a space. I can use this area, nitrogen, the nitrogen. Triple bonding mean 1, 2, 3, 4, 5, and 6 electrons alternative. Okay, and I can explain these 2 electrons of this nitrogen and these 2 electrons of this nitrogen. They are the actually lone pair of electrons. Lone pair of electrons of this nitrogen and lone pair of, so it is the answer. Okay. One of the cations in ammonium iron sulfate is the ammonium ion. Okay. Draw a dotted diagram of ammonium ion. Show out. Okay, we have already done this. It is like nitrogen in the center. 4 hydrogens. 1 hydrogen is here. Second hydrogen. Here we have third hydrogen. Okay. So this lone pair of actually electron is attracted toward this hydrogen. Okay. So we can say this is okay. Now electron of nitrogen, it is hydrogen, nitrogen. So I am representing nitrogen electron with dots and hydrogen electron with this cross. Okay. So he is given the condition. Use that to show electron from hydrogen. Okay. Use cross to show electron in the nitrogen. Okay. So nitrogen electrons are represented by this cross and hydrogen represented by this. Okay. Understand? So now we have this electron pair here, like it is a dative bond. In dative bond, I'm not writing like some like these electrons are like donated toward this hydrogen. Okay, it is a dative bonding. Okay, and overall charges, if I draw their charge, positive, because now nitrogen is using this extra lone pair of electrons. This is the shape of ammonium ion and predict the bond angle. So we can say it is a tetrahedral in shape. Okay, tetrahedral, and in case of tetrahedral, in ammonia it is 107, and in ammonium it will become 109, 109.5 degree. Okay, in simple ammonia it is 107. SO2 react with the, okay, let me make it correct. Okay, no, fine. Now, SO2 react with water to form sulfurous acid. Sulfurous acid is a weak Bronsted Lowry acid, while sulfuric acid is strong Bronsted Lowry acid. Okay, so I think he is asking about the structure of sulfurous acid. So complete a dot and cross diagram to show the bonding in molecule of SO2 to outer. So S sulfur from group 6. So these are the lone pairs of sulfur 1, 2, 3, and 4. And it is electron of sulfur and sulfur. And it is electron of oxygen and oxygen. So now I will like draw the remaining lone pairs of electron. Okay. So no, this is double bond. It is just like this. S double bond O, double bond O. And here I have just lone pair of sulfur and lone pair of sulfur. I need to draw another electron pair here, this. Now oxygen electrons 1, 2, 3, and 4. So just like this, lone pairs, 2 lone pair on this and 2 lone pair of electron on this. Okay, 1, 2, and 1 and 2. Okay, the elements sodium to chlorine. Okay, in SO3, each oxygen atom form a double bond with the sulfur. Okay, SCl2. Name, draw, okay, shape, molecule. Okay, so now we have SO3. SO3 mean, my bad, I think I made a mistake here. This is a one lone pair, not two lone pairs. This is a one lone pair because 6 electrons. So here is also a one lone pair of electrons. My bad. Okay. So here we have SO3. SO3 mean we have this double bond with this, and double bond with this. And what about this? Here we have this oxygen is a central atom, and it is connected with this chlorine, and it is connected with this chlorine. We will have these two lone pairs of this, and 1 2 3 4 5 6, 1 2 3 4 5 and 6. Okay, so we know this lone pair of electrons, they occupy more space and they actually repel. So this is a bent shape. Okay, explain why the melting point SiO2 is much higher than of SO3. Okay, SiO2, the silicon oxide. Okay, so now we need to draw the shape here, and it is the sulfur. This is the one oxygen, other oxygen, and it is the third oxygen. Okay, so now we have this like double bond is there, 4 electron, 1 2 3 and 4, 1 2 3 and 4. So it is oxygen, oxygen and oxygen, and there is 1 2 3 and 4. I'm representing cross electrons for oxygen, so lone pair. Each oxygen will have two lone pairs of electrons. Lone pairs mean 4. Okay. So just like this, we have this chlorine. So oxygen bonded with this chlorine. Single bond is here, and here is also a single bond. Okay. So oxygen have these lone pair of electrons, and now chlorine is making this lone pair of electrons. Okay. 2 3 4 5 and 6. Okay. What's the geometry? It is a trigonal 120. It is a 120 angle. Bond angle is 120 because it's a trigonal one. Okay, trigonal and 120, and it is just like a water. It is a bent shape. Bent shape is the bent, and now it is bond angle is around 104.5, just like water. Okay, water contain hydrogen, but still central atom is oxygen with two lone pair of electron, and they are repelling these bond pairs. Okay, so here we have this question: why the melting point SiO2 is much higher than SO3? We know SiO2 is a sand formula. It is a sand, and we know SiO2 is a giant covalent. SiO2 is giant covalent solid, and SO3 is simple covalent gas. Okay. Next question is the elements sodium to sulfur react with chlorine. Predict the shape of AlCl3 and PCl3. Okay. So what is like similarity and difference? Okay. So aluminum is from group 3. Aluminum is from group 3. It has 3 electrons in its valence shell. So bonded with one chlorine, like this. Here's the one chlorine, other chlorine, and we have this third chlorine. But phosphorus is from group 5. It has 5 electrons. Aluminum has 3 electrons, 1, 2, 3, and is a chlorine 1, 2, and 3. Okay. So it is the shape is actually trigonal. It's making trigonal shape. Aluminum, chlorine, and chlorine is making trigonal shape. Okay. But what about this PCl3? Phosphorus is from group 5. It has 5 electrons. 1, 2, 3, 4, 5. So this lone pair of active electron is repelling this bond pair. It is the making bond with this chlorine, and this chlorine. Okay. Its bond angle is 120, trigonal, 120 degree. Here we can notice like this lone pair of electron occupy more space, and it is repelling these bond pairs. So it is making 107 degree bond angle. Okay, because why bond angle is less? because this lone pair of electron are repelling these two bonds. It is the reason. Okay. The next question is, we are just about to end. I think 110 pages are, and currently I am page number 94. No problem. I will continue until I done. So AlCl3, PCl3. Okay. So I think this is the same AlCl3. Let me change the background. Okay. AlCl3. Shape is trigonal. Trigonal. And what is the angle is 120. Angle is 120. PCl3. It has a lone pair of electron. Cl. Cl bent because lone pair of electron is repelling these things. And the shape is, we know, pyramidal, just like ammonia. It's making a like it's a shape of like pyramid. Okay. It is making a shape of like pyramid. Okay. And angle is 107 degree. Okay. Draw the dot and cross diagram of molecule of SiCl4. So silicon is from group 4. When silicon is from group 4, it is very simple, just like Ca3. Cl, Cl and Cl and Cl. Because silicon only have 4 electrons in their valence shell, no lone pair. There is no lone pair of electrons. Okay. How can I draw this structure? Silicon, I will draw this silicon. One chlorine is here, second chlorine, third chlorine, and the fourth chlorine. Okay. It is a silicon, electron with this silicon, electron with cross. Okay, and cross and cross. So dot is electron of chlorine. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Chlorine, 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 and chlorine. Okay. So that element tellurium react with chlorine to form a single solid product with the relative formula 2070. Product contains 52.6 chlorine by mass. State the type and bonding and structure present in this chloride and explain your okay. So this chloride melt 224, like a little bit higher melting point. Okay, and 270 is the okay. Reacts with water. Understand? What type of bonding is there? It is a tellurium and chlorine. Tellurium is metal. Okay, high melting point number 1. This ionic bonding is there. This ionic compound. How do I know? High melting point and reacts with water. Yes. I think I am writing melting is 2 to 4. Is it very high? Is it low? It's a low melting point. Because an ionic compound, for example, NaCl, it contains 801 melting point, which is very high. So it is covalent in nature, not making ionic. Okay. So I to just rearrange this area. Okay. So low, it is covalent in nature, covalent bonding, covalent bonding. Okay, what is the reason? First reason is low melting point, and other reason is reacts with water, like it is hydrolysis. Okay, and like it went through you can write a proper sentence from your marking scheme. Okay, went through hydrolysis. Okay, it is the reason it is covalent. Tellurium proton 52 is used in photovoltaic cells. Okay, photovoltaic cells. Okay. When fluorine gas pass over tellurium at 150, the colorless gas TEF6 is formed. So it is TEF6. It means there's a tellurium, one fluorine, second fluorine. Now draw the diagonal form like this. Okay, when you have 6 things surrounded a central metal, so you should draw in such a way. Okay, so now fluorine is here, another fluorine, fluorine, and fluorine. Okay, so the diagram is octahedral. When there are six surrounding molecules, surrounding elements to the central metal or central element, it is octahedral. So dot and outer electron. So I have this drawing this tellurium, one fluorine here, one fluorine in the bottom, other two on the diagonals. One is here, other is here, here, and here. Okay, it is tellurium. I'm representing tellurium electrons with cross. 1, 2, 3, 4, 5, and 6, and these are electrons of this fluorine, and it is a fluorine. The fluorine. Okay. So the next thing is, now I need to draw their lone pairs. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay. So the molecular formula C3H6 represent the compound propene and cyclopropene. Okay, propene mean carbon and carbon. When there is E and E, when there is E and E, it means there is carbon to carbon double bond. Okay, now two hydrogens, because each carbon make four bonds. Carbon is making 1 and 2 and double 3. Okay, and he is also explaining it is cyclopropene. Cyclopropene means when there is a cyclic form. For example, we have this carbon connected with this carbon, and now two hydrogens here connected with this, this, and this. Okay, okay, it is. So now, what is the question? Next, I will make like atomic structure. P is equal to nRT and this type of. I will solve that chapter. Okay. So already given. Sorry. What is the CSC bond angle at the terminal CA2 group in propene? So we know it is sp2 hybridized. It is sp2, and in sp2 just try it is 120. Okay, it is 120. Why? Because this carbon to carbon double bond. Okay, let me make this HCH bond angle terminal. Okay, he is talking about this. He is asking this bond angle, this, because this carbon is sp2, because this carbon is connected 3, 1, 2, and 3 elements. When a carbon is connected with 3 elements, 1, 2, and 3, it is sp2 hybrid, and the bond angle in sp2 is always 120. Okay, it is sp3 because connected 4 things, 1, 2, 3, and 4. sp3 and its bond angle is 109.5. When ammonia gas is mixed with hydrogen chloride, white solid ammonium chloride is formed. When ammonia gas mixed with HCl. Okay, state each type of bond that is present in one formula unit of ammonium chloride and how may. We already have solved this. Okay, state each type of bond. You know this covalent, coordinate covalent, coordinate covalent, and ionic bond. How? I already solved this question. Once again, nitrogen is making covalent bond with this hydrogen, and one of the lone pair of electron is attracted toward this hydrogen. It is a dative bond. Because nitrogen is making 4 bond, it is attractive with the Cl negative. So it is ionic bond, coordinate covalent bond, and 3 covalent bonds. Okay. The question refer to elements in this section of the periodic table show below. Okay, group 1 element, group 2 transition elements, and other. From this list of elements, identify each case one element that has properly described. Give the symbol of the element as element whose molecules contain pi bond. I don't know. The question refer to the element in section of periodic table shown below. Okay. From this list of elements, identify each case one element that has the properly described. Give the symbol of the element an element whose molecule contain a pi bond. Pi bond contain O2, we know. Pi bonding is in like oxygen to oxygen, this possible. When there's a nitrogen making, this element is making, there's a possibility of pi bond as well. And so I'm writing this nitrogen. More accurate is the nitrogen. Okay, an element. So nitrogen I'm writing. Okay. You can even check the please marking scheme. Chlorine react with both bromine and iodine to form BrCl through ICl replace. Okay, make it correct. Okay, now it is BrCl and ICl. Melting point is given. It is -101. It is -66 and ICl is a 24. Is a bigger one. Okay. Show outer electron dot and cross diagram of the bond in ICl. In ICl, melting point is higher, and this melting point is higher. So it means here we have only I, not ICl. Okay, this is the bond between I and it is Cl. It is Cl and it is I, and it is making a one. It is making just like I, Cl. Okay, so remaining I can say 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. So let me check on the internet as well. ICl. Okay, ICl bonding structure. So yeah, my structure is good. Yes. Okay, just for verification. So now we have next question. It is okay. Question number 36. Chlorine reacts with other elements group 7 to form number of okay. CIF3A, CLF3 is 12, melting point 12, and BRF3 is 127. Two molecules of similar electronic configuration show outer electrons like dot and core diagram of bonding against CLF3. It is CLF3, is it? Yeah, chlorine. It means we have this chlorine and we have this three fluorines. One fluorine is here, other fluorine is here, and third fluorine is here. So now it is electron of this chlorine, chlorine, and chlorine, and it is a fluorine, fluorine, and fluorine. It is a chlorine. So there are 7 electrons. So it means this chlorine has lone pair of electrons. 1, 2, and okay. So if I rearrange, yeah, it is the structure. Okay. Because chlorine contains 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7. These are the lone pairs of chlorine, and remaining are the electrons of this. Cross is the electron of this fluorine, fluorine, and fluorine. So now you can draw the remaining electrons, lone pairs of these fluorines here, here, and here. Okay. Okay. Carbon sulfide, disulfide is a volatile flammable. Volatile mean which is evaporatable at ordinary temperature, room temperature. Okay. The sequence of atom in CS2 molecules sulfur to carbon to sulfur. Okay. Oh, it is easy. Already I think we have done this. Okay. Just like this. CS2. Sulfur is a central atom. Here we have this carbon. I already solved this. You can check from the sulfur has lone pairs. Okay, they are actually repelling this. It is a structure, but I already drew a structure like dot and cross. You can check from the previous question. Okay. Ammonia is a weak base. Okay. Describe when the aid of an equation the formation structure ammonium ion. Okay. Ammonium ion. It's a weak base. Okay. So we have this ammonia, Na3. Sorry, make it more. Okay, I have this ammonia, Na3 and H3. It has just lone pair of electron, and this lone pair of electron is like this H positive, and now we are getting this dative bond product ammonium ion. So this ammonium ion, there will be a positive charge. Okay. May June 24 shapes of molecules. I think it is important one topic. A molecule of SCl2 contains Cl2 bonds. Create the shape of okay and bond angle molecule SCl2 by using Vesper theory. We know the first thing is how can we predict? Sulfur is from group 6. Sulfur is from group 6. Okay. Sulfur is from group 6. There are 6 electrons. 1, 2, 3, 4, 5 and 6. Chlorine can make single covalent bond. Is making a single covalent bond here and making a single this electron of chlorine. Okay. We know this bond lone pair occupy more space and lone pair of electron they repel this bond pair. So shape is bent or V shape we can say it is just like this, okay, like this. It is a V shape, even we can say bent, and the bond angle is 1/4. Okay, so shape is we can say a V shape or bent. Okay, bond angle is 104, I think 0.5 degree. Okay. Excess of Cl2 react with phosphorus. Okay. PCl5. Okay. So next page. Here we have. So the question is PCl5 simple molecule in gas phase. It also exists in solid form as two ions PCl4 and PCl6. Okay, what's the shape of this PCl5? Phosphorus is from group 5. Phosphorus is from group 5. And this group number will tell me number of electrons in the valence shell of this. It means it is phosphorus P. And here I have a 1, 2, 3, 4. But the fifth electron bond, one of the bond is beyond that. Okay, it is Cl, 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 Cl and Cl. Shape is I think bipyramidal. It is shape is bipyramidal. Bipyramidal. Okay. And PCl4 is tetrahedral. And what about PCl6? So PCl6 would be a octahedral, I think. PCl6 would be like this. We have this phosphorus. 1, 2, 3, 4, 5 and 6. Okay. I told you when there are 6 surrounded elements, so the shape will be octahedral. Okay. This shape will be octahedral. Octahedral. Okay. E react with F2 at 150 to form T. Okay. This. Okay. Now question is okay. TF are octahedral with bond angle because 6 are there. X mean now there are 6. Octahedral with bond angle of 90. Why TF is octahedral with bond angle of 90? It means there are 6 F atoms surrounding surrounding to whom? T element. Okay, it is the reason. Okay, when there are six, the shape will be octahedral. Okay, suggest the shape of molecules of H2S. H2S shape of the molecule. We have this sulfur, lone pair, lone pair, lone pair, lone pair, bond pair with this hydrogen, and we know this lone pair of electrons, they are repelling this, so the shape is bent. Shape is bent. Okay, bent or V shape. We can say the bent or V shape. Bent or V shape. Okay. Sulfur S8 react with chlorine to form several different chlorides. The most common S2Cl2 and S. Okay. So here we have some isomers. I need to like make it correct. Okay. Isomer 1 and here is isomer 2. Suggest a value for the C-CS bond angle in isomer 1. So bond angle is here. Just we need to, here we have this lone pairs, they are repelling this bond. It will be actually like this, sulfur and bent. They are bending this chlorine and it is bending this sulfur. Okay. So this bond angle is 104. 104 point bent. Explanation, lone pair of electrons, okay, lone pair of electron of sulfur repel bond pairs. Okay, available lone pairs, lone pair of electrons on sulfur repel Cl and sulfur repel bond pairs. Okay, bond pairs. So next is sulfides are compound that contain sulfur but no oxygen. Carbon sulfide is a volatile liquid room temperature and pressure. CS2. It is easy like CS2. Carbon can it is like double bond with this carbon, double bond with this sulfur because there is no lone pair of electron on this sulfur. Okay, it is the reason. Great linear shape. If he's asked about the shape is the linear, I don't know the next question. And the bond angle is 180. Bond angle is 180 degree. Okay. So the next question, I don't know what type of question he will ask now. Okay. Background white, white, white. Okay. Suggest the bond angle in a molecule of CS2. Bond angle is 180 because it's linear. Okay. 180. PCl5, PCl3 and NCl3 are halides of group 15 elements. NCl3 is yellow liquid that can be used to bleach floor. Okay. With the shape of NCl3 molecule and CL3 bond angle, we know it is just like HCl. It is just like NH3. We have this nitrogen and 3 chlorine. 1, 2, and 3. Chlorines are there, and we know there's a lone pair of electron on each nitrogen, and it is repelling this bond pair and this bond pair. So in ammonia case, NH3, it is similar to NH3. It is similar to NH3. Okay. So bond angle is 107 and the shape is pyramidal. So what is the shape? Pyramidal. Pyramidal. And bond angle is 107. I think 107 or 107.5. Please check the marking scheme. Okay. So now calcium nitrate react with ammonia, carbon dioxide, water to form mixture of ammonium nitrates. Okay. So we have name of shape. It is just like CS2. It is just like CS2. Like it is carbon double bond with this oxygen, and name of shape is linear. Name of shape is, I'm writing the answer here, linear. And what is the bond angle? Bond angle is 180. Bond angle is 180. Okay. Na3. I already solved this. Shape is pyramidal. Shape is pyramidal. And what's the bond angle? It is 107. And what about this water? It is just like we already done multiple time. Oxygen, hydrogen, and this lone pair. So V shape or bend shape. And bond angle is 104. Sorry if you can hear this background sound. There's some vendor and he is selling something in my street. Okay. So H2O, its bond angle is 104, I think 0.5 degree, and the shape is, you can say, bent or V shape. You can say it is a V shape molecule. Okay. Selenium is a group 16 element. Okay. Selenium react with fluorine to form SEF6. Predict the shape of SEF6. Once again, selenium. How to draw F6? Straight line, then straight line, then diagonal and diagonal, diagonal and diagonal. Okay. So it is octahedral shape. It is octahedral. Shape is octahedral. Okay. So next we have draw a dot and core diagram ammonium ion. I think we already have done this multiple times. Okay. State the shape of ammonium ion and give the H and H bond angle. Ammonium ion shape is like this. Dative bond, covalent bond with positive charge, and each bond angle is tetrahedral. In tetrahedral, bond angle is 109.5 degree. Okay. To the next. Shape bond. Okay. Sulfur dioxide, already I think we have done this, SO2 and SO3. Okay. Shape of SO2 is, shape of SO2, it is S2, and this lone pair of electron. Okay, it is repelling. So shape of SO2 is bent or V shape. I'm writing V shape. And bond angle is V shape is 104.5 degree. SO3 is SO3 trigonal, 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 I think planar, trigonal planar, and bond angle is 120. 120. Okay. Crude oil is processed to give a wide variety of hydrocarbons. Alkanes and alkene can both to obtain from crude oil. Create the shape of each molecule terms or even our atoms to an ethane and ethene. Shape. Okay, we know ethane is just like this. And there is carbon sp3 hybrid carbon. And when carbon is sp3, the shape is tetrahedral. Okay, the shape is tetrahedral. So ethane is tetrahedral shape. Tetrahedral. What about ethene? Ethene is sp2 hybrid. Ethene is sp2, like carbon to carbon this bond, and it is connected with this hydrogen and with this hydrogen. We never count pi bond in geometry. Keep it. There is a pi bond, you know. It is a pi bond side by side overlapping, and we never include this pi bond in geometry. Keep in your mind. So geometry is like this. It is a tetrahedral. Okay. Geometry is in ethene is tetrahedral. Trigonal. Really sorry. It is trigonal. Okay. Please. It is trigonal. Explain why these molecules have different shapes in terms of the carbon-carbon bonds present. The reason is carbon-carbon. They have single and double bond. Okay, they have single and double bond, or even you can say they have different hybridization. Ethane has ethane has single carbon to carbon bond, single bond, and ethene had double carbon to carbon bond. Okay, please rewrite this sentence properly. Okay. Sulfur react with fluorine to form SF6. State the shape and bond angle. So shape of SF6 is octahedral. We already have done this. It is octahedral, octahedral. And what about the bond angle of S? It is 90 degree. Okay, there is 90 degree. How? I think I drew this here. Here, I think no. No shape is here. Okay. So the valence shell electron pair repulsion is a model of electron pair repulsion. Okay. Complete the table below by using simple hydrogen containing compounds. One example has been included. Okay, it is available on the next page here, and the background should be white. Must be white. Okay, yes. So number of bond pairs and lone pair of electrons, shape of molecule. Okay, now we okay. So number of bond pairs. It means there is some central atom X, and it is surrounded by. There is no lone pair. Like one Z is surrounding it, other Z, third Z, and four Z. Just like this here, there's no lone pair on this axis. Okay, so what is the shape? It is tetrahedral. This tetrahedral. Okay, tetrahedral. Please, you can write it by yourself. And you know CH4, we can write it CH4 methane. Okay, carbon has no any lone pair of electron. Okay, number of bond pair, 3 bond pairs and 1 lone pair of electron. It means he is talking about ammonia. Ammonia has 3 bonds pair, 1, 2, 3. Even you can also write this instead of ammonia, you can write pH3, you can write as well, because nitrogen and phosphorus, they both are from the same group number 5. Even you can write it here PCl3. PCl3. PCl still has 1 lone pair of electron, 3 bond pair with chlorine. Okay, I'm writing this ammonia, and shape is pyramidal. Shape is pyramidal. Okay, so shape is pyramidal, pyramidal, and example is Na3. Okay, 2 lone pair, 2 bond pairs. I think water is the best example. Water. Okay, we have this oxygen with 2 lone pairs on the central atom. Lone pair must be on the central atom, and 2 bond pairs, one hydrogen and other hydrogen. Okay, so shape is bent or V shape. I'm writing it here bent shape because of space, and example is H2O. What will the shape of the TEF6 molecule? Octahedral. Octahedral, okay. And what is the TFT bond angle? It is 90 degree, okay. It is 90 degree in octahedral shape, okay. Ammonia and methane are the hydrogens. Okay, let me explain how it is 90 degree. For example, we have the center TE and 1, 2, 3, 4, 5, 6. It is F. There is each bond is around 90 degree. Okay, it is making 90 degree bond. Okay, so the shape of we have done this already. Ammonia like this. Okay, is a lone pair of electron. And what about the CH4? It is tetrahedral. Tetrahedral. Okay, It's a pyramidal, and it is tetrahedral. Tetrahedral, okay. Next. Carbon disulfide is a volatile flammable liquid which is produced in small quantities in volcano, such as the shape CS2. Carbon, C, sorry, because there's no lone pair of electrons, linear shape. Shape is the linear shape, okay. The next. So the bond angle in linear shape is 180. The bond angle in linear shape is 180, okay. I should change this, okay, 180. So assume all bonds, okay. The sulfur forms the compound, okay. S4N to nitrogen, okay, shown below, okay, very good. So determine the number of lone pairs of electron around nitrogen atom and sulfur. We know sulfur there are two lone pair of electron because sulfur is from group 6. Sulfur is from group 6. So one of the bond is bonded with this nitrogen and this nitrogen. So we will have two lone pairs of electrons on each sulfur, okay. Two lone pairs. Okay, determine number of lone pair of electron, nitrogen atom and sulfur. On nitrogen atom, okay, nitrogen can make three bonds. This is from group 5, but here nitrogen making two bonds. It means two, and there are two lone pair of electrons. Nitrogen atom has two lone pairs, two lone pairs, okay. And sulfur atom also contain two lone pairs. But it must make three bonds. But it's making nitrogen is making two bonds, okay. Understand. Next is which bond angle A or B in SN4 molecule will be smaller? So we have one bond between sulfur to sulfur. It is bend shape, and bend shape bond angle is 107. It is 104. And what about this nitrogen? Is nitrogen is making bond with this sulfur and with this sulfur, and there are also two lone pairs of electrons, okay. I think like this. So they are also making same bond angle. Sulfur is bigger in size, but it geometry depends upon the number of valence shells and bond pairs, bonding electrons on the valence shell of this. So which bond angle A or B and SN4 to which bond? I think both are same. Both are same because they both are same. Both A and B bond angles are similar because they both have same number of bond pairs and same number of lone pair of electron. It is the reason, okay. So the next question is 18 May June. Just we are near close to finish. Suggest a value of OCS bond angle. So draw dot and OCS. Okay, carbon is in the center. Here we have this carbon, double bond with sulfur, and it made double bond with oxygen. It doesn't matter like if lone pairs of electrons are here. Doesn't matter. They will never change the shape of the molecule. Important thing is the central atom. If central atom has lone pair of electrons, a lone pair of, then the shape will change. Okay, but it's a linear shape. Value of bond, it is a 180. Bond angle is 180. Okay, and dot and draw cross diagram for this. So it is easy. It is the carbon in the center, the sulfur, and here we have this oxygen. Okay, so it is carbon in the center, and electron of this carbon, electron of this carbon, electron of this sulfur, carbon, sulfur. Because double bonding is there, and lone pair of electrons are here. here and here, and here and here. Okay, it is sulfur, it is oxygen. Okay. Lactic acid and pyruvic acid both contain two function groups. Okay, what type of carboxylic acid and alcohol function group is there? Okay, alcohol function group carboxylic. And what about this? Is Ca3CO? It is Ca3 C double bond O. Okay, it is carbonyl. Even you can say ketone. Okay, it is carboxylic and it is ketone because it's connected with two carbons. Okay, so what's the question? Now it is from intermolecular properties. Okay, shapes of molecules has been done here. Okay, so now we can notice. Okay, label the hydrogen bond, show any relevant dipole lone pairs of relevant hydrogen bonding is possible. Here we can say to make more hydrogen bond, it is positive and it is negative. Okay, it is positive and it is negative. Name the strongest intermolecular force that exists between Na3 hydrogen bond. One Na3 molecule to another is hydrogen bonding. Hydrogen bonding. Okay. Draw a diagram to show the formation of the strongest intermolecular force between the two molecules and it include relevant dipoles. Okay. So now we have this one on nitrogen lone pair, hydrogen, hydrogen and hydrogen. And we have this other hydrogen, nitrogen. So what is the hydrogen bond? When electropositive hydrogen attracted towards the lone pair of other highly electronegative atom. Electropositive hydrogen attracted towards the lone pair of other highly negative atom, electronegative atom. Okay. Melting point of ice and ammonia is short. Ice 273, ammonia 19. Suggest two reasons for the difference in the melting point of ice and ammonia. In case of ice, we have two lone pairs of electrons. In case of ice, it is the water. In ice, there are two lone pair of electrons. Pair of electrons. While in ammonia, there is one lone pair of electrons. Okay, so ammonia is actually making one covalent bond, and in ice it is making two hydrogen bonds. Okay, it is the reason. Okay, so the next is okay. Compound, we have this overall dipole moment, it is zero. Why it is zero? Because they repel each other, they cancel out the effect of each other. We know this is a linear molecule, oxygen, double bond with carbon and double bond with oxygen. It is partial negative, and it is partial. So the bond dipole movement from positive to negative, and it is also from positive to negative direction. It is a vector quantity, they cancel out. So overall dipole moment is zero. Okay. So the which one a dipole moment? There is possibility of this. And what about this sulfur? There's no, because sulfur is partial negative, and it is positive. Okay. And oxygen, big sulfur has lone pair of electrons, so it actually bent. Okay. And the direction is from positive to negative. from positive to negative. I think there's also cancellation. So I think this one also it has, okay. Okay, the next question is the reaction of ethene with the one mixture of CO2 is shown. Okay. Identify all types of van der Waals forces that are present between molecules of this. It is an aldehyde group. It is CH3, CH2, C double bond O, and H. So it can like develop some dipole interaction with other hydrogen of this. Okay. So what van der Waals dipole? Okay, there are dipole forces. Dipole type of van der Waals force. Okay. The next is SCl2 is Mr103, liquid Spr2, one of this gas. The difference in the physical state of SCl2 Spr. So we know chlorine is more electronegative, okay, and bromine is less electronegative. So there is strong in SCl2. In SCl2, there are strong bond energy. Even you can say bond energy, and intermolecular forces. Inter intermolecular forces. Okay. So the next is some of reactions of C are shown here. Why C is very soluble in water? Because of this, because of hydrogen water. We can see it's a alcohol, and alcohol is soluble in water because of this hydrogen bonding. This part is alcoholic, it is hydrogen bonding. Okay, hydrogen bond. Okay, next we have nitrogen is also gas at room temperature. Neither CO nor NO2 is an ideal gas. Complete the table by naming all the type of intermolecular forces in separate sample of nitrogen and CO. If we compare them, nitrogen is making triple bond with nitrogen, so similar atom. There's no electronegativity difference. Okay, so there is a like a non-polar permanent. This is not a polar molecule. But if we see carbon make triple bond with oxygen, it is electronegative and it is electropositive. So it is a permanent dipole. It is a permanent dipole, and it is a permanent non-polar. Okay, permanent non-polar. Okay, understand? So now we have to predict the type of. We know like in N2 is like there's no proper dipole. Okay, so it is like induced dipole, or even you can say they are like most preferable is induced dipole. They have only induced. Even you can say they have instantaneous dipole for a very short time. Instantaneous. Okay, dipole, and here we have CO because already we know there's a like electronegativity difference, and they are permanent. They are permanent dipole. Okay, to suggest why the bond in molecule of CO contain a dipole moment. It is the reason because there is like it is electronegativity difference. Okay, because carbon and oxygen they are different. Differences in electronegativity there is electronegativity electronegativity difference. Okay, it is the reason. Okay, nice. Okay, so next we have carbon monoxide, nitrogen are both diatomic molecule. Nitrogen is less reactive than CO. Even N2 has lower bond energy than Cu. Suggest why. We already explained this, like carbon monoxide has a dipole and nitrogen is a simple molecule. Okay. Co is permanent dipole molecule. Co is permanent dipole molecule. Okay. It is the reason. While we know the nitrogen is non-polar. Nitrogen is non-polar. Okay. Methanol has a melting point minus 96.6 and boiling point this. Okay. So what is the question? The seal faucet, lead faucet will is at constant temperature. Vapor pressure is then measured at 170 kilopascals. So just explain why vapor pressure of water at room temperature is lower than the vapor pressure of. It means the hydrogen bonding, the forces of attraction in water molecules are stronger. That's why their vapor pressure is lower. Okay, and we know, like in water molecule, in H2O, we have these two hydrogens. Okay, like there are two hydrogens bond per molecule in water. In H2O, there are there are two hydrogen bonds two hydrogen bonds per molecule, okay, per molecule, while in alcohol, in methanol, there is only one hydrogen bond, okay. So it is the reason in water more energy is required to overcome these forces, okay. One hydrogen bond. How? Let me explain how, okay. For example, here we have the structure of water, and here we have two lone pairs of electrons, okay. These two lone pairs of electron can attract this hydrogen of other molecule of water, and this even can like attract this hydrogen, partial positive hydrogen, okay. And in case of alcohol, we have only R. Methanol is like CH3 on the one of the side, oxygen lone pairs, and hydrogen, okay. So we can say in this alcohol, one of the end is bonded with CH3, other end is with this hydrogen. So this possibility of only one hydrogen. But in water molecule, we can say like lone pair also attract this two hydrogen. If I ignore this, okay. So these two lone pairs can make one hydrogen bond with this molecule, atom of this, and so there are two hydrogen bonds per molecule. Here is one hydrogen bond per molecule. Okay. So here more energy is needed to overcome these forces. Okay. So gallium trichloride molecules, they're in gas form, and you can say like at 500 degree, okay. And gallium is similar property aluminum and its compounds, okay. Type of these are like you can say like temporary dipole, we can say induced dipole, okay. Induced, induced or temporary dipole, okay, or temporary dipole forces, okay. Next we have CH3CHO is used in the synthesis of some antibiotics. Two reaction sequences are shown. Okay, next page. We are here, and so now in the first sequence we can say we have this aldehyde, and this aldehyde, it is a reducing agent. The aldehyde being reduced into some alcohol, primary alcohol, and we have this aldehyde group, and here we have oxygen like being oxidized. Oxidation of aldehyde gives us carboxylic acid. Okay. And this when this carboxylic acid react with alcohol T, we will get this ester. It is an ester, okay. So A is in some carboxylic acid, a solid at room temperature. So let me draw the structure of this. A connected with 3CH3. It is solid at room temperature, and here we have this C double bond O, and OH. There's hydrogen bonding. Because of this, there's a possibility of hydrogen bonding. And here is an isomer of AB liquid. Okay, there is some ester. Okay, explain the difference in the physical state of A and B with reference to any intermolecular forces may exist. Okay, so in A, in A, there is hydrogen bonding. There is hydrogen bonding. Okay, while in this case we can see there's no hydrogen bond. There's weak intermol, like it is Ca3, and with this oxygen, C double bond O, then CH2 two times, and then there is Ca3. So here is just like induce, okay, in B, like you can say like this temporary dipole, okay. So it is the actual basic reason, and we can say like there's a weak van der Waals forces, okay. Weak van der Waals. In B there are weak van der Waals forces, okay. Weak van der Waals forces, okay. So next, suggest with reference to structure bonding why SiH4 is a gas at room temperature, because it's a simple molecule. It's a simple molecule, okay. And we know there's no dipole-dipole interaction. Like silicon is in the center and with 4 hydrogens. So there's no great electronegativity difference or there's no polarity, okay. So we can, so there's non-polar. We can say it's like temporary induced forces because of temporary, even temporary induced forces are permanent non-polar. It is a permanent, it is permanent non-polar. There is no polarity. Non-polar covalent molecule. Covalent simple molecule. Okay, simple. It is the reason. Simple molecule. Okay, right. The next question we have is, it is carbon to hydrogen, silicon to hydrogen bond have weak dipoles. Carbon 2.5 electronegativity, hydrogen 2.1, silicon 1.8. Why methane has no overall dipole moment? Methane, if we notice in methane, carbon has electronegativity of 2.5, okay, and hydrogen has electronegativity of 2.1, so the difference is 0.4. So there's a very small difference. There is very small electronegativity difference. Electronegativity. Electronegativity difference between carbon and hydrogen. Difference between carbon and hydrogen. Okay, it is the reason. Next we have iodine is an element in group 17. Okay, let me change. Okay, now it is fine. This list all of the force attraction present in solid iodine. Identify which of these are overcome when solid iodine heated produce iodine vapor. So because it is a like van der Waals forces. Iodine is a non-polar. We know when iodine make a single bond, covalent bond with iodine, so it's a non-polar. It is actually a non-polar, and the type of forces are like weak van der Waals forces. They are weak van der Waals forces. Okay. So when like you heat it, okay, they will get only like instantaneous dipole. Instantaneous dipole mean it is non-polar, but when it comes close to such polar, then very for a very short time they will get some polarity, but overall it is a non-polar molecule. Okay, so here we have next question. So forces of attraction overcome. So what type of forces? Van der Waals forces. Okay, Van der Waals forces, because it is overall it is a non-polar molecule. Okay. So next we have a boiling point of F85 HCl 188 CF22773. It is some ionic compound. Calcium is metal, fluorine is a non-metal, covalent compound, non-metals, and is a simple element. Okay. This is why the boiling point HCl higher than the F2. HCl is a polar. Okay. We know this. H positive and Cl negative. It is a permanent polar. And if we talk about F and F, they both are similar. Okay. HCl is permanent polar. HCl is a permanent polar molecule. Permanent polar molecule. Okay. Polar molecule. While FF, okay, it is non-polar. It is induced, or we can say it is a non-polar. Okay. And in HCl, there is a like good electronegativity difference. Okay. So next we have this. HOF is the only known molecule that contain only three elements: hydrogen, oxygen, fluorine. Okay, pure HF is a colorless liquid. The liquid contains HF molecule that having strong hydrogen bond. Draw fully labeled diagram to suggest how a hydrogen and bond can form between two HF. Okay, we have this hydrogen fluoride, H and F, and we know there are lone pairs of electrons on this fluorine, and these lone pair of electrons of fluorine attracted towards this neighboring hydrogen, partial positive hydrogen. Okay, it is actually hydrogen bonding. Okay, so question 15, October number 17. Explain in terms of structure and bonding why the melting point of SiCl4 is much lower than NaCl. We know NaCl is an ionic compound because it is a metal and non-metal. Silicon is a metallite, okay? And the other thing is NaCl is an ionic, like giant ionic. It is an giant ionic compound, while SiCl4 is a simple, it is a simple covalent molecule. It is a simple covalent molecule, right? Okay, so we have this next question is only 2 pages are remaining, luckily. Okay, so explain why the melting point SiCl4 is higher than PCl3. We know like it is also a giant, it is also a giant. Okay, but what is the reason? So we could like easily predict there in SiCl4. Okay, so it is a simple molecule, van der Waals forces, dispersion forces. Okay, but in case of NaCl as giant, already have done this. Okay, so what is the reason? Explain why the melting point SiCl4 is higher than. So we can say there's a more number of electrons, and in PCl3 there's a less number of electrons. Okay, in SiCl4, ICl4 there are more number of electrons than, because they both have like same covalent, same, they both are simple covalent. Okay, it is mentioned in your textbook. Okay, name the strongest type of intermolecular forces in ice. Hydrogen bonding. Okay, Okay, next. Draw a fully labeled diagram water molecule in ice showing the forces 1 and 2. Okay. So if we have this water molecule and oxygen and this hydrogen, so this lone pair of actually electron, it is making a hydrogen bond of other hydrogen atom of water molecule. Okay. The partial positive is making covalent bond with this lone pair of oxygen. Okay. Explain the meaning of the term bond polarity. Bond polarity mean when one of the element has negative and other electronegativity difference, even you can say. Okay. Why the boiling point H is much higher than the boiling point of other hydrogen halides? In HF, high melting, you can say bond energy is bigger and boiling point is 19 higher. In HF, there is hydrogen bonding. There is hydrogen bonding, but in other halide there is no hydrogen bonding. Okay, hydrogen bonding, and you can say there's a great bond energy. Okay, high bond energy. Other reason you can say higher bond energy. Okay, higher bond energy. Okay, suggest and explain for the increase in boiling point from methane to butane. We can say number of atoms are increasing. Okay, you can say mass is increasing, number of atoms are increasing. Okay, number of atoms per molecule are increasing. Okay, understand? So it is the reason the isomer of butane to methyl has a boiling point 261. Suggest explanation for the difference between the value of that for butane in the table. Okay, isomer butane to methyl propane. Okay, now we have two isomers. He is telling one isomer is a simple butane CH3 and CH2 and CH3. There are four carbon. It is a simple butane. Its other isomers is 2 methyl propane. So he is talking about this CH3 carbon, then CH3, and it is making the isomer here CH3. Okay, so this one has high boiling point, and this although the number of carbon atoms in both and hydrogen are same, but this one has low boiling point. So what is the reason? We can say the surface area is higher surface area, and here we can say lower surface area. In straight chain, surface area is higher, like more connectivity. Okay, more surface area, more surface area, more connectivity, more connectivity of atoms. Okay, it is the reason they have higher boiling point, but they have low boiling point. Okay, so next question, next page number 107, and last is the 108. Okay, here ammonia is a polar whereas methane is non-polar because in ammonia. Okay, explain using ammonia as example the meaning of the term bond polarity. You know, electronegativity difference in one of the element contain partial positive, other contain partial negative. Why the ammonia molecule is polar? Due to electronegativity difference. Due to electronegativity difference. Electronegativity difference. Okay. Okay. State one physical property of ammonia which is caused by its polarity. Physical property. What is a physical property? It's a gas. High boiling point because this is okay. High boiling point. High boiling point. Okay. Boiling point. okay, as compared to neighboring molecules. Enter physical property, okay. By considering your answer A, B, predict the physical property of BrCl at room temperature and pressure. Okay, BrCl. Interaction with, okay. Physical state, what do we think is a physical state? It would be like, because it's a covalent in nature, we can predict could be some liquid or gas. Like this is small gas, small electronegativity difference, okay. I think the information of question is missing. It could be a gas. According to me, I think it is a gas because small electronegativity differences there between Br and Cl. Question information is missing actually. That's why I'm like writing it casually, okay. The next question is melting point Cl2 Br is -6 and ICl. Okay, yeah, it is like gas. If I check from here minus, so it is a gas, okay, not a liquid. It could be in a liquid state because melting point 24. Why the melting point increase from Cl to ICl? Because electronegativity difference is increasing, okay. Electronegativity difference increase. Electronegativity difference. Electronegativity difference increase. Suggest which of these three molecules has the largest permanent dipole? This one. Because there is I and Cl, it is partial negative and it is partial. Let me check. Chlorine, then we have chlorine, then we have bromine, and then we have iodine. Okay. So down the group electronegativity decrease. So one of the bond is I and Cl. Yeah, there's a big difference. Another is Br and Cl. Yes, I and Cl. Okay. Explain your answer. So we can write a large electronegativity differences there. This is a permanent polar molecule. Okay. So we can write in detail and down the group. Even you can like draw this and you can explain this. Okay. Because down the group electronegativity decrease and there's like a big difference between ICl bond and higher electronegativity difference as compared to this. And in Cl2 there's no electronegativity difference and it is a non-polar molecule, while BrCl is a polar but it is weaker than ICI. Okay, so you can combine all these points. Even you can discuss melting point of these things. Okay, so the last page finally. Okay, so the compound C once again 12 melting point and BRF3 is 120 suggests why the boiling point is significant different because there's a huge electronegativity difference. Okay, there's a huge electronegativity difference between this and this. Okay, and there's a although they both are permanent polar. Okay, dimethyl DM is a gas at room temperature. Ethanol liquid, which intermolecular effects between ethanol molecule which cause ethanol to be a okay, it is a like hydrogen bonding. Okay, in ethanol there is a hydrogen bonding. Diagram show intermolecular forces of what? Intermolecular forces you should okay in ethanol. Ethanol is actually C2H5 making this oxygen with this hydrogen, and this lone pair of oxygen will attract the hydrogen of this alcohol. Okay, it is the type of bonding and everything is done from 2012 to 2024. The most